Imagine for a moment that you are standing in a vast dark room, surrounded by 1,000 candles flickering and dancing in the air. Each candle represents a star, and the entire room is the universe. Now picture yourself as a curious teenager, peering into this room, trying to understand why the candles move the way they do. This is the story of how some of the greatest minds in history tried to unravel the mysteries of the heavens, and how their discoveries changed the way we see the world. In the 16th century, the world was a place where the heavens and the earth were deeply intertwined. People believed that the stars and planets moved in perfect circles, guided by divine will. This idea was so deeply rooted that it was almost taken for granted. But there was a problem. The calendar, which was supposed to track the movements of the sun and the seasons, was off. The vernal equinox, which marks the start of spring in the northern hemisphere, had shifted from March 21st to March 11th. This shift was not just a minor inconvenience. It affected everything from farming to commerce. Farmers couldn't rely on the calendar to plant their crops, and merchants couldn't depend on it to sign contracts for the delivery of seasonal goods. This discrepancy was a clear sign that something was wrong with the accepted theory of the heavens. The old Ptolemaic system, which placed the Earth at the center of the universe, was not working. This is where a brilliant but controversial figure named Nicolaus Copernicus enters the story. Copernicus was a Polish mathematician and astronomer who lived in the 16th century. He was deeply troubled by the errors in the calendar and the inconsistencies in the Ptolemaic system. He believed that there must be a better explanation for the movements of the planets and the stars. In his groundbreaking work, De Revolutionibus Orbium Celestium, on the revolutions of the celestial spheres, Copernicus proposed a new model of the universe, the heliocentric system, which placed the sun at the center instead of the Earth. This was a radical idea, and it was met with skepticism and resistance. The Church, which had a strong influence on society, was particularly opposed to it because it contradicted the teachings of the Bible. Copernicus himself was cautious and did not publish his work until he was on his deathbed. However, his ideas sparked a revolution in astronomy that would change the course of history. One of the key figures who built on Copernicus's work was Erasmus Reinhold, a young professor of astronomy at the University of Wittenberg. Reinhold was fascinated by Copernicus's ideas and saw the potential to create more accurate astronomical tables. He spent 7 years working on a set of tables called the Prutenic tables, which were far more accurate than any previous tables. These tables became the standard in Europe and were even used by Pope Gregory XIII to reform the calendar in 1582. The new calendar, known as the Gregorian calendar, is still in use today. While Reinhold's tables were a practical application of Copernicus's theories, they did not fully endorse the heliocentric system. The Church was still wary of such a radical shift in cosmology, and Reinhold's work was presented in a way that did not challenge the traditional view. The next major figure in this story is Tycho Brahe, a Danish nobleman and astronomer who lived from 1546 to 1601. Tycho was a man of many talents and a somewhat eccentric personality. He lost part of his nose in a duel, and wore a prosthetic nose made of gold and silver. Despite his aristocratic background, Tycho had a deep passion for astronomy and dedicated his life to observing the heavens. Tycho's observations were incredibly precise, thanks to the sophisticated instruments he built and the meticulous methods he used. He cataloged the positions of over 1,000 stars and made detailed observations of the planets. His work added more to the stock of astronomical facts than anyone before him. However, Tycho was not convinced by the heliocentric system. He believed in a compromise system where the Earth remained at the center, but the planets revolved around the Sun, which in turn revolved around the Earth. This system, known as the Tychonic system, was a middle ground between the Ptolemaic and Copernican models. On his deathbed, Tycho bequeathed his observations to a young and brilliant mathematician named Johannes Kepler. Kepler was a passionate Lutheran and a deeply religious man who saw the study of the heavens as a way to understand God's design. He was convinced that the universe was governed by mathematical harmony and set out to find the underlying patterns in Tycho's data. Kepler's work led to the discovery of 3 fundamental laws of planetary motion, which are still taught in astronomy today. The first law states that the planets move in elliptical orbits with the Sun at one focus. The second law states that a line segment joining a planet and the Sun sweeps out equal areas during equal intervals of time. The third law states that the square of the orbital period of a planet is proportional to the cube of the semi-major axis of its orbit. These laws were a major breakthrough because they provided a clear and accurate description of the movements of the planets. They also made the heliocentric system more plausible by showing that the planets' orbits could be explained by simple mathematical laws. Kepler's work laid the foundation for the modern era in astronomy and paved the way for the work of Sir Isaac Newton, who would later explain the forces that govern the motions of the planets. The story of Copernicus, Reinhold, Tycho, and Kepler is a testament to the power of human curiosity and the relentless pursuit of knowledge. These men challenged the accepted truths of their time and pushed the boundaries of what was known. Their work not only revolutionized our understanding of the universe, but also demonstrated the importance of observation, mathematics, and critical thinking in the scientific process. Today, we take for granted the fact that the Earth orbits the Sun and that the planets move in elliptical paths. But it is important to remember the pioneers who made these discoveries possible. They were not just scientists. They were brave and visionary thinkers who dared to question the status quo and seek the truth. Their legacy lives on in the way we understand the universe and our place in it. So, the next time you look up at the night sky and see the stars and planets, remember the story of Copernicus, Reinhold, Tycho, and Kepler. They are the unsung heroes who helped us see the universe in a new light, and their work continues to inspire and guide us as we explore the mysteries of the cosmos.